For example 3, find the critical points of the following autonomous first-order differential equation. Classify each critical point as asymptotically stable, unstable, or semi-stable. Sketch the typical solution curves and the regions in the xy plane determined by the graphs of the equilibrium solution. So, go ahead and let's find the critical points. Looking at this, setting our differential equation equal to 0, our critical points are going to be y is equal to 0. It's like positive 2 and positive 4. All right, so again, you can make a horizontal line, or if you want to go ahead and straight to the vertical line, go ahead. I'll go ahead and make a vertical line. And that goes to negative infinity to infinity. We'll have values at 0, 2, and 4. And what I'm going to do is I'm just going to plug in values in between and then determine if it's going to be positive or negative. So let's go ahead and pick a number between negative infinity and 0. Let's say negative 3. If we choose negative 3, it's going to have a negative, positive, positive. So we're going to be negative. So it's going to be going downwards. Between 0 and 2, let's pick 1. So we have positive, 2 minus 1, positive, and then positive 4 minus 1. And so we're going to be positive for 2. We pick 3, do the same thing. 2 minus 3 is negative, 4 minus 3 is positive. So we're going to be negative, 2 positives and 1 negative. And then when we do, say 5, we're going to have a negative and another negative, but then a positive, so we're going to be up at 4, or above 4. All right, so let's go ahead and graph the solution curve, and we're done. So this is not going to take very long. And so here we'll have an xy plane, and we're going between we're going from 0 to 4, so I'm going to go ahead and just move this down a little bit. Make that straight. Alright, and so, again, critical points are at 0, 2, and 4, so I'm going to go ahead and draw my lines there. So there's my line at 0, my line at 2, and then my line at 4. Alright, and we're told that our first one, well, below 0, we're going to go downwards. So I'm going to go ahead and start left, and then I'll go ahead and make our way downwards. And then from 0 to 2, we are going to start left, and we're going to work our way to 2. And then to the between 4 and 2, it looks like we're going to 2, and so start up at 4, head down to 2, and then 4 looks like we're going up, so we're going up. So there's the graph, and then we need to tell, okay, are they attractors, repellers, so our critical points. So for a critical point of 0, it looks like it's, they're both going away. So when they're both going away right here, it's like B, and so B is a so it's a repeller. So 0 is a repeller. The next, this has it in terms of stable, unstable, semi-stable. So a repeller is also known as unstable. So yeah, I'm sure you would be confused there. So again, stable is when it is an attractor, unstable is when it's a repeller, and semi-stable is when it actually says semi-stable there. Alright, so 0 is unstable. Our next one is 2. 2, it looks like they're tending towards 2, so that one is going to be stable. And then 4, so I'll just say 4 and 0 is unstable because they both tend to go away from 4 there as well. And so no semi-stable ones. And that's it. Again, if you have any questions, come back to see me. But that will be it for today's notes. Tomorrow I'll put 2.2, which is going to be very easy because that's all Calc 1. Or sorry, well, parts of Calc 1, Calc 2. And we're